In this video, we're going to look at another transformation. This one is called a reflection. So a reflection, what it does, it flips a shape across an axis of symmetry or a line of reflection. So what that's going to be is a kind of an imaginary line that if we took our paper and folded on that line, the two shapes that we would have would line up exactly on top of each other. So we'll look at examples of that in just a minute. Just like a translation, a reflection and a shape and its reflected shape are congruent, meaning they have the same size and the same shape. Different from a translation, now the two shapes face in the opposite direction. Okay, so think about when you look in a mirror, sometimes you know when you hold up your right hand, it looks like it's your left hand, right? So it's kind of the opposite direction. Okay, so the main difference between a translation and a reflection: a translation faces in the same direction, a reflection faces in the opposite direction. Okay, a good way to think about reflections is to picture folding your paper, and if the points line up, it is a reflection. Okay, so we're going to do some examples in just a minute, and we'll look at how the shapes change. However, there are some changes in coordinates that will work every time that we could memorize to help us either double check to make sure we're doing getting the right coordinates, or just to go from here at the beginning and not have to worry about reflecting our shape over the actual line of symmetry. Okay, so look here, it says if we reflect over the x-axis. Okay, so that's our horizontal axis. What's going to happen? This is our original point. The x-coordinate will stay the same. The y-coordinate will become opposite. For example, if we had the point 1, 2, reflect over the x-axis, now we have 1, -2. Okay. Similarly, if we reflect over the y-axis, the up and down axis, our original point, xy, will become opposite of x, and the y will stay the same. So let's use the same point. If we had 1, 2, and we reflect over the y-axis, now we have -1, 2. Okay? The last two here are a little bit more challenging because they're diagonal lines. The x-axis is a horizontal line, the y-axis is a vertical line. So even if we don't remember these rules, we can remember, hey, this point was 2 units to the right of the line, so now it's going to be 2 units to the left. Or this point was 3 units below the line of reflection, so now it's going to be 3 units above the line of reflection. However, with the diagonal line, it gets a little more tricky. We can still count the units, and we'll see that in just a minute, but we have to be careful because we kind of have, we're counting diagonally and we kind of have half units in there. But these will work every time. If we reflect over the line y equals x, okay, so this is in slope-intercept form. That means there's no plus or minus anything, so that means the y-intercept is 0 and it goes to the origin. Y equals x, there's not a number before x, so we could say the coefficient of x is actually 1, which means our slope is 1. So our line would go through the origin, and it would be up 1, right 1, up 1, right 1, and it would be a positive diagonal uphill slope. So here's what happens. For every point we have, all we do is we switch the coordinates. So if we had the point 2, 3, now it becomes 3, 2, and that's our new point. The other line we could reflect over is y equals -x. So that's the same thing, it goes to the origin. However, now it is a downhill negative slope through the origin. So our original points, they swap, xy becomes yx, and they become opposite. Okay, so one step further from y equals x. Okay, so now let's look at some examples. All right, so numbers 1 and 2. So let's look at number 1. It says reflect across y equals -2. So what I'm going to do is I'm going to take this Sharpie and I'm going to draw the line of reflection. And I'm going to do that with a dashed or a dotted line. Okay, so y equals -2. All right, so if this is the origin, that's y equals 1. So let's go in the other direction. This would be y equals -1 and y equals -2. Okay, we can think about hoi. Okay, y equals a number, that's going to give us a horizontal line through that number. So -1, -2. So here is our line of reflection. Okay, so now what we do is we take each point of that shape, of that polygon, and we are going to reflect it over that line. So each point is going to be the same distance above that line as it was below the line. Okay, well, if you notice, our first point is on the line, so it just stays there. Okay, so that's I prime. Now E is 1 unit below, so it'll be 1 unit above the line, E prime. Z was 1, 2, 3 units below, so it'll be 1, 2, 3 units above. Okay, so that's Z prime. Q was 1, 2 below, so it'll be 1, 2 above. That's Q prime. So now we can connect our points, and we have our new shape. Okay, so if we were to fold our paper over this line like that, then those two shapes would line up exactly. Okay, so now this wasn't one of the lines we talked about. We talked about the x-axis, the y-axis, y equals x, y equals negative x. However, we still need to know what those lines are. That's y equals -2. Okay, number 2 says reflect across the x-axis. Okay, so here's the x-axis. Draw our line of symmetry there. And however far above these points are, they're going to be the same points below, right? But if you remember, if we reflect over the x-axis, our original points, the y coordinate becomes the opposite, okay? So for every point we have, if we want to look at it that way, we could think keep the x coordinate the same and just make the y coordinate the opposite, okay? And so now if we want to count, we can do that. So A is 1, 2, 3 above, so it'll be 1, 2, 3 below. So there's A prime. D was 5 above, it'll be 5 below, D prime. M, same way, 5 above, it'll be 5 below. Notice how my points are staying in line here, right? Because they're just reflecting right over. And W is 4 above, so it'll be 4 below. And be careful how we connect our points here. The same segments that are connected, or the same vertices that are connected in our original figure, will be connected in our new figure. So W to M, M to D, D to A, and then W to A. And we have our new shape, okay? All right, number 3 says reflection across y equals -x. So remember, -x, that's gonna go through our origin, and it's gonna go downhill just like this. So if I went down one, right one, my line is going right through all of these points right here, okay? So that's my line of reflection. All right, and there's 2 ways we could do this. Okay, we're going to start off by counting the units, and we'll see if we can get the correct reflection. All right, we have to be careful here. Okay, so we have J. So if you notice, J, to get to the line, is kind of like half a unit away. All right, it wasn't a full diagonal unit away from the line of reflection. So our new point will be halfway away again. So that's J prime. Now if we look at T, 1.5 to get to the line, right? So there's half and then 1 full unit away, so T prime. A now was just 1 full diagonal unit away, so A prime will be 1 full diagonal unit away. S was 1, 2, 3, so it'll be 1, 2, 3 in the other direction, okay? So now we connect our point, S to A, S to T, T to J, and A to J. And we take a look and we have our new shape. But remember, if we want to talk about the coordinates to check, if we reflect over y equals -x, our coordinates become opposite and they flip. So we would say it's -y, -x, or the opposite of y and the opposite of x. So let's test a point here to see if that matches up. Okay, let's look at point S. S is 1, 2, 3, 4, 1, 2. So S is 4, 2. So S prime should be -2, -4, right? 1, 2, 1, 2, 3, 4. And we are there. So if you see there, they swapped. 4, 2 became 2, 4, and then they also became opposite. Okay. All right, we're going to skip number 4 because it's similar to number 1, y equals -2 and y equals -1. All right, let's look at number 5. Number 5 says reflection across x equals -3. So not one of the original 4 lines we talked about. However, just like Hoy tells us horizontal, we can think about Vux, x equals a number, that's going to give us a vertical line through the number. So where is -3 on the x-axis? Well, -1, -2, and -3. So our line of reflection would be a vertical line of reflection right through -3. Okay, so now every point that's to the right of that line is going to be the same distance to the left and vice versa. So W was 1 right, it'll be 1 left. S 1 right, S prime 1 left. I was 2 left, so I prime will be 2 right. P was 1 left, P prime 1 right. Connect your points, P to I to W, W to S, and S to P. We have our reflected shape. All right, number 6 says reflect across y equals x. So now this is a positive slope going through the origin with a slope of 1. So there is our line of reflection, okay? So now we take a look and we could count the distance away each point is. Once again, be careful with the diagonal line here, okay? So if we look at L, L is 1 full unit away. So it'll be 1 full diagonal unit in the opposite direction. H was 1, 2.5, right? That's not fully across, that's 2.5. So go 2.5 in the opposite direction. So there's half, and then 1 and 2. And there's H prime. Q was 1.5. So there's half and 1. And there's Q prime. And P was just half. So half this way will be P prime. Now in this one, be careful because these points are kind of hard to tell which points should go where or how you should connect them. So connect it exactly as it is over here. P to Q. So P to Q, Q to H, Q to H, H to L, and then L to P. And there's our new shape. Okay, so let's check to see if our coordinates are right here. So if we think about how the coordinates change, for a y equals x, all we do is swap the coordinates. So whatever xy is, now that's yx. Okay, so let's use h for example. H, the coordinates for point H, -1, -2. So -2, 1, 2, 3, -2, 3. So following this rule here, H prime should be 3, -2. So let's check that. 1, 2, 3, 1, 2. And that will work for all 3 of the other points. All right, so now let's look at this a little bit differently. Let's think about, our Sharpie kind of bled through a little bit, but let's see if we can look at these shapes and find the line of reflection. So this won't take as long. Okay, so look up here. Does it look like there's a horizontal line of reflection, a vertical line? Well, if we check, okay, now we can look at each of our points. So F is up here, F prime is down here. So it looks like our line of reflection is a horizontal line just like that. All right, so now F is 1 above, F prime 1 below, K 1, 2, 3, 1, 2, 3, J is 1 above, 1 below, and V is lined up as well. Okay, so now what is the equation of this line? Well, it's horizontal, so it's y equals, and then we have 1 and 2. So y equals 2 would be our line, okay? All right, number 8. Looks like we have a diagonal line here, right? Because U to U, V stayed there, T to T, and D was right there. Okay, so if we're looking at our line here, it's gonna be a negative diagonal line through the origin. Okay, so that is going to be y equals -x is our line of reflection. All right, number 9. Number 9, see how R and R are right here? W and W, G, G, A, and A. So our line of reflection would be our x-axis. Okay, all right, number 10. P is here, P is here, P prime is here. So our line of reflection has to be a vertical line. And it looks like it splits right here. Okay, so that's x equals 1, 2, 3. So x equals -3. Okay. All right, once again, a vertical line for number 11. All right, we have P and P prime, U and U prime, and we can see that the middle of these two shapes, or where we could fold them across, is right there, and that is the y axis. All right, last one, another diagonal looks like, because U is coming diagonally, right? 1 unit there, 1 unit over there. So this is going to be our diagonal positive slope through the origin. So we would call this y equals x, okay? So remember, on a reflection, the objects will face in the opposite direction. And once again, a big idea with reflections is that the shape stays congruent, okay? That's a reflection.